Let's be real for a second. When you hear the word math, what's the first thing that comes to mind? For a lot of us, it's probably boring formulas and tests. But forget all that. We're about to go on a journey that shows you what math really is, the hidden language of the entire universe, from how your phone works to how we get to Mars.
So let me ask you straight up. Do you think of yourself as a math person? Or does the thought of numbers kind of make your palms sweat? Whatever your answer is, just hold that thought. Because I think by the end of this, you're going to see the whole thing in a totally new light.
Now get this. This is an actual problem from a real math competition. Seriously. There are no numbers, no equations. It's about using pure logic to build an argument. It's creative, it's funny, and it's the side of math that, we just don't get to see in school.
But how do you get from 1 plus 1 to proving why someone shouldn't break up with geometry? To get there, we've got to go back. Way back. We need to start where all of humanity started.
It all starts with an idea so simple that we teach it to toddlers. The idea of one more. I mean, really think about that. You start with one, just a single thing. But the moment you add another one, something incredible happens. You invent a completely new idea, the idea of two. And from there, just by repeating that one simple step, you can build every single number in existence. That is the very first spark of math.
Okay, so we've got numbers. But a giant pile of numbers isn't that useful on its own, is it? We need a way to talk about them, to describe what they're doing. So we invented a language, a universal language that works the same way whether you're in New York or Nepal.
The very first words we learn in this language are symbols. Like the plus sign, the equal sign. They're basically shortcuts. They let us take something happening in the real world, like putting two things together, and write it down in a simple, clean way.
This right here, this is basically the C-spot run of the math world. It's a complete sentence, a statement that is absolutely 100% true, no matter where you are in the universe. Everything else, and I mean everything, is built on top of this simple truth.
But of course, we don't talk in simple sentences our whole lives. We need a way to talk about things that change, like the speed of a car or the price of a stock. And for that, we bring in letters, like X and Y. We call them variables because they can stand in for any number we want. And this beautiful little equation isn't just a statement anymore. It's more like a recipe, or even a piece of code. It describes the perfect, graceful arc of a ball thrown through the air, or the shape of a satellite dish. This is where math takes a giant leap from just counting things to actually describing how the world works.
So you might be wondering, okay, but why do we really need all this X and Y stuff? Well, it's because it lets us solve problems that for centuries were thought to be completely impossible. Problems like, how do you measure something that's, unmeasurable?
I mean, we all remember this from school, right? Finding the area of a square or a rectangle is easy. It's just length times width. Boom, done, simple.
But what happens when you have a shape like this, one with a curved edge? Suddenly, length times width is totally useless. There's no simple formula. And for hundreds of years, this question stumped the smartest people on the planet. The answer required inventing a whole new kind of math, calculus.
Okay, so here's the absolutely genius idea. You can't measure the curvy shape directly, right? Fine, so let's approximate it. Let's try to fill it up with simple rectangles. One big rectangle is, a pretty bad estimate. 2 is a little better. 4 is getting closer. Now, here's the wild leap of imagination that is calculus. What if you could fill that space with an infinite number of impossibly thin rectangles? The fit would be perfect.
And that mind-bending idea, adding up an infinite number of tiny little pieces, is called integration. It's a tool that lets us do the impossible. It lets us find the exact area of any weird, curvy shape. And honestly, it's one of the most powerful ideas anyone has ever had.
But here's the thing. Integration is just one tool. A really, really powerful tool for sure, but still just one. You should think of a mathematician like a master mechanic with a giant garage, and it is absolutely packed with specialized tools for every job imaginable.
So in calculus, you have these two superstars, derivatives and integrals. They're like two sides of the same coin. A derivative is like looking at your car's speedometer. It tells you your exact speed at this very instant. An integral is like looking at the trip meter. It tells you the total distance you've traveled so far. One is about the right now, and the other is about the whole journey. Perfect opposites.
And trust me, this toolkit is massive. Just for triangles, there's a whole library of formulas. We all know the Pythagorean theorem, right?
Well, that's like the first screwdriver you ever get. There are so many more tools to solve any kind of triangle problem you could ever run into.
And it's the same deal for circles and polygons and pretty much any shape you can dream up. The point is, over thousands of years, we've built up this incredible collection of specialized tools. It's a real monument to human curiosity and problem solving.
So once you have this amazing toolkit, what happens? Well, math stops being just about grinding through calculations to get an answer. It transforms. It becomes a kind of playground for logic and creativity.
And that takes us right back to where we started, with those strange, awesome problems. These aren't about finding a number, they're about using the tools of logic to build a solid argument, a proof.
And I think this gets to the real heart, the real soul of mathematics. It isn't just some frantic race to find the right number at the back of the textbook. It's about the process. It's about building a beautiful, rock-solid argument that no one can poke holes in.
So in the end, math isn't just another subject. It's like a superpower. It's the ability to see the world more clearly, to ask smarter questions, and to build arguments that actually hold up. The tools are all there, just waiting for us. The only question is, what are you going to ask?